Hello, everyone. Welcome to the GeekNarrator podcast. I am back with another episode. Today, we are going to talk about something very interesting, which is PostgresSQL and mainly about its compatibility. So, PostgresSQL is this, gold standard database, open source database, which is pretty popular in relational database world, and it is often compared with MySQL. But Postgres is much more about, much more than a database, and it is an ecosystem. It has all these extensions that makes it even more easier to extend and grow this ecosystem. So we are going to talk about PostgresSQL and its compatibility with other database a lot. And I have Dennis with me, who has joined us to explain all the things related to PostgresSQL compatibility. And so thank you, Dennis. Dennis is currently the head of developer relations at Yugabyte, and I'm really excited to have him to uh, discuss about the Postgres and compatibility and its ecosystem. We are also going to cover briefly about the databases that use PostgreSQL and its compatibility, and how they implement it. At the end, we are also going to show you some demo about how things work in different databases, typically related to PostgreSQL. So, with this, welcome Dennis to the show. Thanks a lot for joining us. And let's start with a brief introduction for our viewers.
Yeah, absolutely. Thanks for inviting. Pleased to be here and pleased to talk about Postgres and Postgres compatible
Yeah.
databases. So what I've been doing and who I am is, as you said, I'm the guy who knows a little bit more about Postgres and about Postgres compatible databases. So what I do, I'm an application developer, actually,
Yeah.
who have been in the distributed database market or segment for the last 8 years. So what I do is like I'm studying distributed databases and distributed systems, and then I am helping application developers and architects to build solutions based on these
Yeah.
distributed systems. So my first
Yeah.
distributed system and database was Apache Ignite. That's a database for high performance in memory computing.
Hmm.
And almost, I think, a year ago, I switched to another database company called Yugabyte. And so by doing that switch, I had a chance to kind of spend more time studying PostgreSQL internals because YugabyteDB
Hmm.
is one of those PostgreSQL compliant databases. And if I, as a head of developer relations, want to build applications that are running on YugabyteDB, or when I'm talking to any application developers, I also want and need to understand Postgres right from inside, and
Yeah.
that's what I do. And by doing this research, and I'm still studying, that's a never ending process that depends on how much time you can allocate daily on looking into the
Yeah.
Postgres, because YugabyteDB is still your primary responsibility. I
Yeah.
mean, it's a joyful, and
Hmm.
this Postgres compatibility talk came out really well. And before Postgres, before all these distributed systems and blah blah blah, I was at some point in my career, I was on the Java engineering team at Oracle. We were developing GVM and GDK, and my actually first job was at Sun Microsystems. I was on the technology evangelism group,
Hmm.
just evangelizing and helping
Hmm.
to use Java, NetBeans, Solaris, and many other technologies produced by Sun Microsystems. But that's it. I think
Awesome.
pretty quick
Yeah,
introduction.
yeah. That's a very interesting experience that you have in the world of databases, and looking forward to learn from you. Let's start with understanding why is PostgreSQL so popular, and why is it on the rise? If we talk about the last decade, for example, and how does it compare with MySQL?
I would say that that will be an opinion of an application developer.
Hmm.
And I'm actually, I use Postgres probably for most of the projects. When I was, preparing for this talk with you, I tried, to trace back and see like when I started using PostgreSQL for real applications creation. And that was, let's say, almost, I think, like 13 years ago, Those days
Mm-hmm.
I was building, let's say, some mission critical backend in Java, and we used PostgresSQL as a
Oh,
database. And those
yeah.
days Postgres actually was less known than MySQL, but it happened then IT administrators loved Postgres so much, they loved community so much that they decided to use PostgreSQL as a standard database for all the transactional workloads. And we use
Yeah.
Postgres. And then over there, like whenever I had any pet project or any, like when I worked for any company, usually Postgres was there. But it doesn't,
Mm.
I'm not trying to say, let's say that MySQL is less popular. It's usually based on the preference of people. Like, because people, we are developers, right? And we architects, like you and I, it's up to us to decide usually what database to use, right?
Yeah. Yeah.
And what I see throughout the last probably 5 or 7 years, what happens? The popularity of MySQL and
Mm-hmm.
like MySQL, Oracle remains relatively the same. MySQL and
Yeah.
Oracle are
Yeah.
still much more, like not much more, but more popular than PostgreSQL. But the growth trend of Postgres popularity is sharper. It inclines
Mm.
so rapidly. And
Yeah.
those of you guys who are interested, like why, how did I come up with this conclusion? Go to the DB engines website. That's a well-known website for those who want to see, try to track the popularity of databases. The algorithm is not exactly clear, but usually they search through the internet. They see how many articles are written about your database, how many discussions on Stack Overflow happen about the database,
Mm.
how many
Okay.
times your database is tagged on LinkedIn and Twitter, etc., etc. And based on all of this information coming from the internet, DB engines build the rank. So Postgres is
Okay.
like in the top 5 databases. Oracle and MySQL are still at the top, but Postgres, growth rapidly.
Okay.
So the question is why, right? Again, I will not give you a precise answer, but my understanding is as follows. Because I'm the guy who spent, when I'm usually doing a switch between companies,
Mm.
I'm looking for the companies who are in the open source world. For
Yeah.
instance, Java is an open source technology. That's why when I used to work for Sun Microsystems or Oracle, I knew that all those code changes that I'm pushing into that repository eventually will be available to everyone. And I had a chance to work with the global Java community. The same
Yeah.
with Apache Ignite. Apache Ignite is an open source database that belongs to Apache, the same place that is home for Kafka, Spark, or Cassandra, or Hadoop.
Yeah.
And YugabyteDB is the same, and Postgres is the same. So Postgres actually, I think what's happening, my conclusion, Postgres probably is becoming the Linux of databases. You know that
Mm.
Linux is probably one of the most dominating operating system. Even Microsoft,
Yeah.
when Satya Nadella, became the CEO,
Yeah.
he said like, yeah, no, let's use Linux, right, for our
Mm.
cloud environment, and that changed Microsoft a lot. Because right now
Exactly.
Microsoft Azure probably is number 2, right? I think for
Yeah.
sure number 2
And it's
cloud.
growing.
It's growing, right? And
Yeah.
I
Yeah.
will not be surprised if at
Yeah.
some point in time Microsoft will catch up with Amazon.
Yeah.
But going back to their, I lost what I was talking about, and this is a good that's a good sign. Just try to say really quick what's on your mind. So this thing about Linux of the databases, right?
Yeah. Yeah.
Because Postgres, and the beauty of the Linux? Linux belongs to the Linux Foundation, but Linux Foundation is not governed on or ruled by any vendor. It's an open
Mm.
source product. You pretty much can
Yeah.
take it and do whatever you want.
Yeah.
The same we can say about PostgreSQL. PostgreSQL is governed by an open source community.
Yeah.
Yes, in that community, you will find representatives from Amazon, from Enterprise DB, from many other companies. But Amazon cannot tell Postgres community what to do, even though Amazon Aurora, PostgreSQL
Yeah.
compliant database, is one of the most popular, one Postgres
Yeah.
compatible DBs. And also, it's up to the community to decide. And this is good.
Mm.
A license is open. You also can do pretty much what you want. With Postgres, just take and use it. Like, do whatever you want. You don't need to contribute back to the community, to the code base. You don't need to pay any royalties. And you know that if I, as a startup owner, or I'm a director of some engineering group at Goldman Sachs, or I
Mm.
don't know, at Barclays or anywhere else, I know that if I take Postgres, this license will not be changed,
Yeah.
and I will not go any worse with the vendor.
Yeah.
MySQL is different. IBM DB2 is different. Oracle is different. We have MariaDB, and but I mean, probably MariaDB is a good alternative for those who kind of want to have that protection, right? So that the license is going
Mm.
to be changed, and the vendor can put a firm grip on the technology. So that's like from the licensing point. That's why I think that Postgres is becoming the Linux of the databases. It's open. It's governed by the
Yeah.
community, and the product.
Yeah.
And apart from that, it's a robust technology. It's a battle-tested database. It
Yeah.
certainly comes with most frequently used features that you will find in any relational database. Apart
Yeah.
from the relational features, PostgreSQL is more than a relational database. You can find
Mm.
time series support. You have different user-defined types. You have full text search support. You have JSON support and blah, blah, blah. There are so many capabilities that are not that standard for relational databases. And also, that's just the core of PostgreSQL. But we have extremely rich and broad ecosystem of
Mm.
extensions.
Yeah.
Like, for instance, did you know that you can just execute Java? Like, you have store procedures, and you can create a store procedure in Java and write it and execute it in PostgreSQL because we have an
Yeah.
extension. Or you can start a special REST API server that will
Mm.
turn your PostgreSQL instance to a REST endpoint, and your
Nice.
application just can send REST requests to that extension, and
Yeah.
extension will translate them into the SQL. So many extensions for all the needs.
Really
So that's
powerful.
from the feature side. So that's why I think so popular.
Absolutely. And thanks for the detailed answer. It gave me also a new perspective. So I now have some pointers to go back and, search a bit more on Postgres, like why, like the extensions that you talked about, and, the cool extensions that you can just convert a database into a REST endpoint and it will work. So great. I think I am convinced why PostgreSQL is the way to go, and why there's a lot of freedom and why there is so much extension going on. Let's talk a bit about the compatibility and what does it mean. So when we say that there are some databases that are PostgreSQL compatible, and what does it mean? What does it mean to be compatible?
Compatible, it means that it can mean several things. And here
Hmm.
is what we will discuss with you in a few minutes. The
Yeah.
compatibility, you cannot, just say like it's compatible because it does A, B, and C, right? Or
Yeah.
it's compatible because it does X and Y and Z.
Yeah.
Generally, like you need to break down things into pieces. We will discuss with you several compatibility levels so
Yeah.
that we
Yeah.
understand, because when someone says that my database is PostgreSQL compatible, you need to
Hmm.
say what's your exact compatibility level, what it means. Are we
Yeah.
talking about just Y level compatibility, when what
Hmm.
it means that I can reuse JDBC drivers or ODBC drivers created for Postgres for your new database? Or is it a feature level compatibility, meaning that I use stored procedures of Postgres because that's my application, right? And
Yeah.
if I
Yeah.
switch to your PostgreSQL compatible database, then I want to have stored procedures and I don't want to
Hmm.
rewrite them from scratch. So generally, why do another, actually, if to quickly jump back to your first question, like why Postgres is so compatible, I
Yeah.
think another justification of why Postgres compatibility level, is going up is that we have so many Postgres compatible databases these days. We have Google Spanner. They added PostgreSQL compatibility probably a year ago. We have Amazon Aurora. Everyone knows Amazon Aurora.
Yeah.
Recently,
Yeah.
Google, again, in addition to Google Spanner, they released YugabyteDB,
Hmm.
that is also Postgres compatible database. We have
Yeah.
Neon, that was released by the founder of Single Store, also PostgreSQL compatible database. And we have CockroachDB, and we have YugabyteDB, and but again, each of these databases can say that they are PostgreSQL compatible, but we will dive into the details. But for
Awesome.
application developers, those are just some information that you can Google and you can do your own research. By why the heck do we even have those PostgreSQL compatible databases? Because
Hmm.
by default, When you create your application, usually you start with vanilla Postgres or MySQL or Oracle. But
Yeah.
then if your application becomes a hit or you come across some challenges, if those challenges cannot be solved by PostgresSQL, or they can be solved by, with some cumbersome or complicated architecture, then you can consider a PostgreSQL compatible database, because this compatibility statement says that it's highly likely that I will migrate my application from Postgres to this new PostgreSQL
Mm.
compatible database with no,
Yeah.
which usually doesn't happen, or
Yeah.
with little changes. So this is the promise, and this is the beauty of compatibility. You migrate there,
Yeah.
and then
Yeah.
if you don't like it, you can sometimes migrate back with some, let's say, code level changes again.
Mm. Yeah. Sounds good. It sounds like, so there is PostgreSQL, the traditional one, the vanilla one, and then people typically start using that, let's say in a startup or something, and then there are some challenges around it. We are going to touch base on, when to use the Postgres and when to use the extended or the compatible databases. But it sounds like it makes the migration from the traditional RDBMS of Postgres to a compatible version of the database, right? Because it is compatible in different sense. So with this, let's start digging a little deep into the compatibility level. So when I say wire compatible, feature compatible, what does it mean, and how many compatibility levels are there?
Yeah, so now let's, because we are going to discuss with you and review 4 different compatibility levels. There might be,
Yeah.
some different compatibility levels. There is no any standardized way, guys,
Yeah.
on how to put those levels. Like the 4
Yeah.
that we're going to discuss today were created by us at Yugabyte, because we spent a lot of the time, working with
Yeah.
Postgres and Yugabyte.
Yeah.
But they're pretty much, easy to follow. So we will start with the wire level compatibility. It basically means that when your application opens a network connection with your PostgreSQL compliant database, then all of
Mm.
the packets that are going to be transferred between that database and your client application are going to be serialized in Postgres protocol. So that's
Yeah.
the wire level compatibility. And
Yeah.
how can you check this Postgres wire level compatibility? Basically, what you do, you can use PSQL, or you can use dbeaver, or you can use any other SQL tool, and you can try to open a connection to your
Yeah.
PostgreSQL compliant database. You open connection,
Mm.
execute a few primitive statements. If you don't see any error, then basically you can say that this database is wire level compatible. So that's the
Mm.
first. And we will see, like, I'll show, guys, I will show you kind of quite several code samples
Yeah.
so that you memorize it better. The next one is syntax compatibility,
Mm.
the second one.
Okay.
It means that after, let's say, my client application and my PostgreSQL compliant database, after I establish this connection after I start exchanging messages using Postgres via protocol, my
Yeah.
application wants to write SQL statements using Postgres syntax.
Mm.
And if it's possible, if you can create tables or indexes or materialized views or execute inserts or do joins following the Postgres syntax, then it's fair to say that this database is
Mm.
syntax level compatible.
Yeah.
So
Okay.
those are the two essential. The third one is feature level compatibility. Because let's take this example. Let's say that the syntax is supported. So you can probably create tables, you can insert, you can do joins, you can do this and that.
Yeah.
But if, let's say, you don't have certain features like triggers or stored procedures or materialized views, then you cannot say that this database is feature level
Feature
compatible.
level. Yeah.
And usually, it's hard to become PostgreSQL feature level compatible, because
Yeah.
PostgreSQL is a venerable database. Like, it
Yeah.
existed for many decades. And the feature set is rich, and it's robust, and it's stable, and it's keep
Yeah.
evolving, which means that usually you will find a much better compatibility level, feature level compatibility level in those
Mm.
databases that are built on the PostgreSQL source code, because
Yeah.
they need to do less job, trying to catch up with features. And final one is runtime level compatibility. So this one is the most interesting. But if you are dealing with a runtime compatible database, it means that the likelihood that your application, like pretty advanced application can be migrated with no or little changes to that other database is high. Because runtime compatibility means that your target database matches PostgresSQL execution semantics in runtime. It basically means that if, let's say, I have the stored procedures, right? Or it basically means that for the ecosystem of applications, drivers, and tools and extensions, your database will not be that different from Postgres because it has system catalog. It shares the same error codes with Postgres. It has probably extensions that are used by some applications. And basically for your tools and applications, this PostgreSQL compatible database will look like Postgres because it's runtime, its execution semantics are the same. So those are 4 levels. And again, when we will be discussing each level, for instance, if a database is not a feature level compatible, it's automatically not runtime compatible because runtime compatibility assumes that you have your feature level compatible as well. And another, guys, important note and remark, there is only one 100% compatible database with Postgres. It's Postgres itself. Because when we are going to talk about even feature level compatibility, I mean, it's not like, yes or no. It's more about like how close you are to the Postgres feature-wise, right? It might be, let's say, 95% close, or like 60% close, or like 99.9. But anyway, 100% compatible database is only Postgres.
Yeah. Awesome. I think that makes sense. I mean, is it because other databases are still evolving and also Postgres is evolving, adding new features, adding new syntax? Is that because it's like no database is like 100% compatible, or is it because it's not possible because the semantics or the design itself is different?
Yeah, that's a beautiful and very, very deep and good question because it depends on an architecture of a Postgres compatible database. Let's take 2 examples. Let's take, for instance, Amazon Aurora and YugabyteDB. Both databases are built on the PostgreSQL source code. So if let's say to take Aurora and YugabyteDB, our query layer or compute layer is Postgres. It's just Postgres source code of a certain version, like something that was released. For instance, it's Postgres 11 or Postgres 13th. And underneath, what's different, like Aurora has its own storage layer and YugabyteDB has its own storage layer. The differences are Aurora is still it's not a distributed database. With Amazon Aurora, you have one primary node that handles and serves both reads and writes. And when we're talking about the fault tolerance or scalability in Aurora, it's usually related to read replicas. So you have this primary node in Aurora, and then you attach read replicas, and read replicas can boost your reads in certain locations. This is what it's for. But ultimately, the storage layer is a single node database. Because I mean, if this primary node goes down, then Aurora can automatically switch to one of the read replicas because synchronization it's like the changes are exchanged synchronously, so you will not lose any data. But it will take time. I mean, it's not instantaneous. It can I cannot throw in any ideas. It might take minute or more. I don't remember the number. I don't use Aurora in production. With YugabyteDB, for instance, the storage layer is also different, but it's distributed. Which means that for Aurora, it's simpler. And Aurora can catch up with Postgres features probably faster because that's Amazon. They have more resources. And their storage architecture is simpler. With YugabyteDB, you have a distributed. Your cluster can consist of 5 nodes, 10 nodes. Those nodes can run across continents, which means that if some of the features are not available, they might be not available because we still need to integrate this feature from the query layer properly into their storage layer. But I would say that with YugabyteDB, it's usually, I mean, there is a special page where we track everything. It's usually we support everything that is used most of the time. I cannot right now say any feature that is not supported by YugabyteDB because usually we don't have any questions related to guys when this feature is going to be supported in YugabyteDB. Usually people just come and ask, okay, I have this YugabyteDB cluster, so how do I configure it for this setup, or like how can I boost the performance like for this? Which means, but still to answer your question, it certainly
Very
depends,
interesting.
because my kind of feeling is that if the database storage is not distributed, then it's simpler. Just my
Yeah,
thought.
absolutely. It's more closer to the Postgres itself. So high chances of being more compatible as compared to other databases that are distributed in nature. And with distributed nature comes new problems, new failure
Oh yeah.
modes, and all that. And it's even more challenging to give the same behavior or the same feature set as the regular PostgresSQL. So I think I can imagine what kind of challenges are handled behind the scenes in distributed systems and specifically databases. Great.
And here is, if you allow me to stop you for a second, because that's a very
Yeah.
important remark. Because usually what I say when it comes to distributed databases such as Google Spanner, CockroachDB, on Yugabyte, immigration of your application can go really smooth. It can be
Yeah.
literally the lift and shift experience. But what I usually say that, guys, even if that was the lift and shift experience, it's highly likely that you want and need to take advantage of this distributed nature, because just
Mm,
your first next exercise, run load tests, run performance tests, find bottlenecks, because right now your queries are running across distributed system, and you might need,
yeah.
let's say, just to introduce this or remove something or add something.
Yeah.
But in practice, it's usually the performance should remain the same. It can go be a little bit lower, but once you understand the distributed nature and distributed kind of patterns and specificities, then you do certain optimizations, and your performance and your scalability, you understand why you switch to distributed system.
Yeah, yeah, absolutely. I just have one more question out of curiosity because I have been part of some of those migrations. We wanted to move away from, let's say, some of the databases, and migrations in a production environment is really painful. And, when you're dealing with live traffic, live customer data, and so many constraints, things might fail during the migration. So, at a high level, if we have to, talk about how this migration is working. So, let's say I have a Postgres database and I decide to move to, let's say, Yugabyte database, right? How does it work? Like, is it still serving the live traffic, the old database, or it's, uh, while the migration is happening, because there can be a lot of data and it can take maybe, let's say, a few days to migrate all that data to the new database. What happens to the live traffic, and any details on that?
Yeah, there is no any silver bullet solution, but usually the first
Yeah.
question you need to ask and answer is, can you allow yourself a downtime? And
Hmm.
usually a downtime, even a minimal, will be needed when you migrate. And if you can allow, then you can come up with several options. For instance, the simplest, if you can allow yourself, to shut down your system for a couple of hours, then you don't need to reinvent the world. Just shut
Yeah.
down your system, then go take a backup and apply this backup. If you need, let's say, if you're not taking YugabyteDB or something else like Google Spanner, just convert this backup to the syntax and to the format of Spanner and load it, right? And I think there are different tools that exist. If you cannot, allow yourself to get to be down for many hours, then you can use something more sophisticated. What we usually did, and my last migration project I was involved like probably 5 years ago. We were migrating. It was one of the largest bank in Europe, and they were migrating from Oracle. And what was happening? They would take a snapshot of Oracle, production snapshot, petabytes of data. They would apply this to a target database, another one, and then they would use Oracle Golden Gate to apply
Mm.
deltas. At some point, let's say, but even in that case with the bank,
Yeah.
Golden Gate would let them just to get to that moment, and then still they shut down their system probably for one
Yeah.
minute or like 2 minutes.
Yeah.
That downtime they allowed yourself, because their regulations was controlled by the government. They were not allowed to go down for more than 3 minutes. Otherwise, they would be paying fines, big fines to the
Yeah.
country. So
Absolutely.
that's like the same as I think with Postgres and etc. You just can take a snapshot, apply it, and you can,
Yeah.
for instance, use some CDC technology. With
Yeah.
Yugabyte, if you're migrating, if your target database is YugabyteDB, then at YugabyteDB, we do understand that migration is one of the first steps and the most painful steps, right?
Yeah.
So
Yeah.
for YugabyteDB, we created a special tool. It's called YugabyteDB Voyager. You can
Mm.
jump on a ship and you can get from one place to another.
Yeah.
And that tool actually allows you to migrate both schema and data from your Postgres, MySQL, Oracle database, and to apply it to YugabyteDB. This tool
Yeah.
doesn't support this, let's say, Delta migration, online migration yet. It's still offline. You need just to take probably shut down the database or just kind of run it alongside, and then you need to somehow apply the changes, deltas. But I think that our plan is on the roadmap is to support the online migration as well.
Yeah. Yeah.
But
Very interesting.
just if to throw in several approaches that I also used, but guys who are listening us, they certainly might have some other options. So if you have any other options, just write down in the comments,
Yeah.
guys, and let's discuss, because it will be
Sure.
curious to see, right? Like, what was your migration plan? What was your migration approach
Yeah.
from Postgres to?
When we migrated, I guess we migrated completely away from Postgres, so not
Uh-huh.
like Postgres compatible. So I think we migrated from PostgresSQL to, let's say, I think Cassandra database, because we chose Postgres for the wrong reasons, I guess. So what we did was it was like application level change. So we tried to write in both databases, and we did that for, let's say, a day. And then we took the older snapshot from Postgres and we tried to bulk upload into Cassandra. And then after, let's say, a week, we ran a job that would compare both the data and make sure they are equal and everything is fine, and then slowly take away the Postgres database and not write at all, and also move the reads to Cassandra. But there was a lot of coordination. There were some application level changes. It wasn't that bad, to be honest, because uh, scale was okay. I wouldn't say very high scale. It was like average scale, maybe, I don't know, 500 requests per second or something. It wasn't huge, but it worked out quite well. But it required a lot of coordination at the application level. So
Yeah,
I don't
that's a
know.
good point. That's a good point. Actually, as while I remember one of the scenarios when I used to work, on a daily basis with the Apache Ignite community. We had such a use
Yeah,
case. One of the telco companies, they wanted to migrate from Apache Ignite 1 to Apache
yeah,
Ignite 2. It's like major versions, which require you just to shut down your cluster. You cannot just have nodes of version 1 and 2 running in the same cluster. So they did exactly
yeah,
what you're saying. They were doing this at the application layer. The application was writing to different
yeah,
databases, and then eventually they did a final switch.
yeah. It works, but it's a little, there are trade-offs. With this, I just have another question regarding this migration. So I assume there are some tools also to kind of validate that once the migration is done, the data is correct, it's all intact, there is no mismatch or data loss or anything like that. So are there some tools supported by these databases that we are going to talk about today?
I mean, yes, I think so. I can speak. Usually, you can do this, by running simple script. That the number of rows is the same,
Yeah,
right? And then usually every database, it writes the checksum, and if data was corrupted,
yeah,
you will know about that. And also the migration tool usually does a good job. Let's say the source and the sink, right there, they usually
yeah,
coordinate well. If anything goes wrong, it will
yeah,
highlight this to you. But here is, if to give a deeper question, it usually, what's your source and target database and what's your tool, because
yeah,
but usually, yeah, it's present. You remember, like, even when you download the file sometimes. So right now, many companies don't do this, because probably, like, most of us are switched to the cloud, right? Because we consume services. But I still remember the times when I would download a version of a product, and then alongside with the main download link, there was the checksum link. It's like once you
yeah,
download, check
yeah,
the checksum. I've never used it.
yeah,
But
yeah,
I guess the same exists for the migration tools.
yeah, yeah, I hope so. Great. So let's jump into some of the demos. Let's start with a bit of practical things.
Okay, sure. So what we are going to, let me share the screen.
Yeah,
My screen. So guys, a few demos. We will I've already mentioned wire compatibility, syntax, feature, and runtime. So right now, let's see in practice. For the experiments, we are going to use several databases. There are more than 4 PostgreSQL compliant databases, but we will use 4. You have 4 compatibility levels and 4 databases are selected by me. Google Spanner. A quick introduction. Google Spanner is a well-known distributed database. Probably that's one of the first transactional distributed databases. The beauty is that, let's say, you can run your database nodes across multiple regions and zones, and both nodes, every node can serve reads and writes, and every node keeps a subset of the data. For instance, your record is stored in one availability zone in the United States East, and my record is stored, primary copy is stored in the US Central Zone. And but there are backup copies also all over the place. So, and also I think Google by default, the default SQL engine is written from scratch for Google Spanner. But what happened almost a year ago, I think it was in November 2021, Google decided to introduce the PostgresSQL support. It's still in its early phase, and I don't know how much Google is going to invest into this, considering that YugabyteDB is launched a few months ago. But anyway, it's a good example for our experiments. Right? Similar to Spanner, CockroachDB is a distributed database. You can run it across multiple zones and regions. It's consistent. And they're also similar to Spanner. They are building and developing their SQL engine from scratch. But they did a much better job, in their PostgreSQL compatibility direction. It still takes time, a lot of time for them, to catch up with the feature set of Postgres, but they do this, incrementally.
Yeah.
Now, if to go to Amazon Aurora, Aurora is actually an example of a database that uses PostgreSQL source code. So they basically they go to PostgreSQL GitHub repository, they take one of the versions and they merge it with their Aurora code base. And they, I think, do this just for the SQL engine because the storage engine is pretty much unique to Amazon.
Okay.
So, but again, one important remark here. While Spanner and Cockroach are distributed databases, Amazon Aurora is not.
Okay.
It always has one instance, like the one I show here. It's called the writer instance. All the writes will go to this instance, but you can use read replicas to load balance your read requests.
Makes sense. Yeah.
All right. And next one, another example of a Postgres compliant database that is built on PostgreSQL source code is YugabyteDB. There is a funny story, actually. YugabyteDB was inspired by 2 databases. The first one is Amazon Aurora, and the second one is Google Spanner. Similarly to Aurora, we are based on the PostgreSQL source code because we don't want, let's say, to bring in different Postgres features and try to catch up with Postgres. It's hard. But also we were inspired by Google Spanner because the goal was to create a distributed application that can have nodes in different locations, and all of the nodes will be serving reads and writes, similar to Spanner or CockroachDB. So those are 4 databases that we are going to review for our 4 compatibility levels. Good?
Yeah. Yeah.
Let's go. Let's jump to the samples. So where is my samples? So right now, let me quickly quit. I will show you from scratch. So for Google Spanner, interesting observation. It might sound or look weird to you because I'm going to connect to Google Spanner, but I'm connecting to my local host machine. Why this happens? Because my Google Spanner instance uses Postgres syntax and protocol, which means that Google requires you to download and run PG adapter alongside your applications, and I'm connecting to this adapter. I will be sending all of the requests in Postgres syntax to this adapter, and the adapter will translate them to their syntax and to the protocol of Google Spanner. So this is what's going to happen. You need to have that middleman in your architecture. But once you connect, the connection is established, which says that Google Spanner is already we can talk about it as a while compatible database. Now let's execute a few instructions like
Yeah.
slash d, no any relations. You can check
Yeah.
the schemas. We have some schemas. You can enable this function timing that will return the latency it took to execute your query. So
Yeah.
it's good. Google Spanner doesn't support. It's not 100% wire compatible, but most widely used capabilities and features are there, so which is good.
Yeah. Yeah.
So quickly, the same check, but for CockroachDB. I'm running a serverless instance of CockroachDB. So my instance is running on one of the VMs in the cloud, and that VM is shared by other serverless instances, probably of other guys. So let me connect. I'm connected. Wonderful. Let me also execute a few statements, which mean that from the Y-level compatibility, great.
Yeah.
I'm connecting and I'm issuing different commands. Amazon Aurora, it would be surprised if it's not Y-level compatible. It certainly is. So, but let's, again, for the sake of consistency, let's run the same test. You have this. And YugabyteDB, for YugabyteDB, I'm running a multi-node cluster across several availability zones. Also, let me show you. I'm connected somewhere in the cloud. I'm using Google Cloud. Let me connect. That's a managed instance you can download and install in your premises. I'm using a managed instance. And the same stuff. I have public and some other schema that I use for my application. So that was the Y-level compatibility in action. So just every database is good at that. Man, any questions from your side? Anything else?
I think for Spanner, it was a requirement to have this adapter installed locally, right? And for others, it was because it was just directly you were accessing the cloud, deployables, so it was not needed. So does Spanner have something like that, or it always requires you to have this adapter and run the queries locally?
No, I mean, it's like this adapter can run on any machine. It can, for instance, when you deploy your application to production, this adapter needs to run. It can run on a different machine, and your application is on a different machine, on the same machine, and you issue this request. But again, one remark: you use this adapter only if you selected that you need PostgresSQL syntax for your application. Yeah, if you don't need it, then you don't need this adapter, but your application needs to run and write SQL in the syntax that is supported by Spanner.
So makes sense.
That's what you need to do.
Sounds
Cockroach support this at their node level. I think like every node that receives this request will be able just to get this message and translate it and execute it using the CockroachDB. Aurora and Yugabyte, this for sure. Like we are using PostgreSQL source code, which means that it's easy and obvious. You can open this connection and you can send the requests directly.
Yeah. I also have a question. What is the terminal that you're using?
That's Visual Studio. I mean, that's Visual Studio, and I like it.
Yeah, it's cool. Yeah.
All right. So what's next? Syntax level compatibility. So syntax level compatibility implies that you can write your requests like create tables, indexes, views, inserts, updates, and joins, you following and using PostgreSQL protocol. So here is today, I'm not going to use, any complicated syntax. I just want to run a trivial sample. So here is what you're going. Yeah, let's create table person, insert some values, select data, create an index on the first name, and then we are going to use /d person just to see the structure of this table, like columns, etc. So I'll copy it. I don't want to type it. We don't have that much time. So let's start with Spanner first. All right, so here is with Spanner, it will take some time to create. So usually with distributed databases that are running across multiple zones and regions, execution of DDL statements like create table, create index might take more time because of, and Spanner actually, I have a multi-zone deployment as well. I think it's a three node cluster of Spanner. That's why, create takes more time. But once we are done, let's see what happens. I'm executing. I created, so what's now? Now I inserted these records, and next it's creating indexes it created the index, and then I executed this /d. So generally,
Yeah.
the basic check for the syntax level is good. So at least we can say that Spanner is syntax level compatible. To what degree?
Yeah.
50, 60, 80, or 90%? I don't know.
Yeah.
I mean, it's like we can figure out, but that's not the point of our today conversation. What's
Absolutely.
good is
And
that
that might be like changing with every new version of Spanner or the library that you're using, right? Because these things are evolving. So it can be 60, it can be 70 after 1 year, maybe. I don't know.
it all depends on the vision
Yeah.
that Google has for Spanner. I mean, let's say in a year
Yeah.
from now, because like if guys you're watching recording and that recording was done like a year ago, like hello from the past, some of the features might have already been supported, right? Or I
Yeah.
don't know, like probably Google decided not to invest into the Spanner PostgresSQL compatibility and just
Yeah.
put all the budget into the AlloyDB. And actually, AlloyDB is quite Amazon Aurora, but AlloyDB
Hmm.
also has a lot of enhancements for analytics. But
Okay.
architecturally, AlloyDB is similar to Aurora. It's like one
Yeah.
primary node and read replicas.
Yeah.
But
Fair
anyway,
enough.
that's Spanner. I would say that it's syntax level compatible
Yeah.
with Postgres
Yeah.
to a certain degree. Now let's
Yeah.
do the same with Cockroach. I mean, really fast. Cockroach created everything really fast because that's a serverless instance. It's just basically one node of, I think, Cockroach right now in one of the VMs. That's why it's faster. It's good for development and experiments.
Yeah.
But this /d command failed for CockroachDB because I think they do not. It's that's actually the conversation not about wire level or syntax level compatibility. It's
Yeah.
a conversation about runtime compatibility. It's like guys at Cockroach has not introduced this catalog yet, and this is
Yeah.
why I mean this command failed. But
Okay.
anyway, not a big deal. From most of their stuff was
Yeah.
executed successfully.
Yeah.
Amazon Aurora, all right. I mean, it's gonna be fast, blah blah blah.
Awesome.
And here is you see like how is it different from Spanner, because it's based on their PostgreSQL source code. Like if you
Hmm.
run the same query against Postgres, you will see, I think, identical output. We
Yeah.
have primary key B-tree. We have that secondary index that we created, also B-tree. It's like you kind of feel that, oh, that's Postgres. It's like it's running on
Yeah.
Postgres.
Yeah.
For YugabyteDB, let's do the same. Create an indexes. It will take more time because it's multi node,
Yeah.
but the output of /d person is quite similar to Aurora. The only one difference is here.
The
We
index.
we use our storage engine uses LSM tree, not B
Yeah.
trees,
Yeah.
but the rest of the output is the same that you would
Yeah.
get with Aurora or Postgres.
That makes sense.
So that's syntax level compatibility. I think it's more than enough. Man, any
It's
questions or any
it's very
remarks?
interesting. I actually did not pay enough attention to the index type that you mentioned. So it is very interesting that you mentioned for Aurora, because it's kind of Postgres. So it uses B tree and all those kind of indexes, and Yugabyte. I think for CockroachDB as well. It uses LSM based architecture. So I
Mm-hmm.
don't know if it showed that output here for CockroachDB.
Cockroach, no, like I tried to use the /d person, but
Ah,
it's not supported, like because of this missing
yeah. Okay.
catalog. It's runtime level. The guys at Cockroach definitely have another way of showing this. I just don't
Yeah.
know that. I don't want to speak for
Yeah.
them.
Yeah.
It's just easy to
Absolutely.
Google.
And
That's a
what
trivial
was
problem that you can solve.
absolutely what was on Spanner? Because
For Spanner, they basically say they don't display this
okay.
this
Okay.
information.
Okay. Interesting.
But what's their tree? I don't remember. It
Yeah.
probably no. Let's not confuse people. We can
Yeah.
check
Yeah.
it later. We can Google
Absolutely.
for it. What type of tree it might be?
Absolutely.
B tree or LSM tree.
Yeah. Yeah. Absolutely.
Anyway,
Cool.
next one, right?
Yeah.
Let's go to the feature level compatibility, because right now we are
Yeah.
getting into the interesting territory. Syntax and wire compatibility are the basics.
Yeah.
It means that at least if you take a JDBC driver or any Rust driver or Node.js driver, or you connect to
Yeah.
the tool, you will be able to manage it. But now I'm an application developer. I have some applications, right, man?
Yeah.
And those applications were written for Postgres. So and then how much of an effort, how much of a pain, or how much of a joy it would be for me to migrate that application to a PostgresSQL compatible database.
Yeah.
For our feature level, and that actually depends first on the features, because
Yeah.
what features do you use? If you use like all these primitive features like insert and blah blah blah, it's going to be easy, right? But if you
Yeah.
use stored procedures, triggers, if you run joins and subselects, then you can migrate and then you can do optimizations and all of that sort of stuff.
Yeah.
For our experiments, I took a simple application. It's called a market orders application. So what it does, imagine just one Java backend. That Java backend is connected to PubNub public stream. That stream generates mock stock exchange trades. Like people buy stocks, people sell stocks. I actually connect to the stream from my Java app, capture all of those purchases, and then I write all this information into my database.
Yeah.
So the application, where is it? It's quite simple. Let me show you the source code. The schema is trivial. So we have the buyer table, we have sequences, because I don't want to generate, IDs for buyer and trade. I have, timestamps. I use one materialized view because I print some statistics. So like that's a pretty simple, crude application. Receiving stream of stocks, different trades, and then I'm writing this to my database and then execute some statistics. So now let's run this application. And this application by default was created for Postgres. And I used it for Postgres. And then let's try, that's for instance how the Postgres, I'm using PostgresSQL driver here, JDBC driver, and that's, let's say, connection details if you run Postgres on your laptop. So now we are starting with Google Spanner, right? It was first. So I'm not changing. The beauty of this wire and syntax level compatibility for this simple application, that's a trivial application, is that I don't need to change any source code. What I do, I'm changing only connectivity settings. So you see for Google Spanner, I continue using Postgres driver because wire level compatibility. And then I'm connecting to this PG adapter that is running on my local laptop. So let's do this, man. Where is my connection stream? Did I close it? Yep, I close it, but we can quickly jump back. So that's their, let's do it this way. I'm sorry. Yeah, we don't need this. That's different. That's the final application. And that's our, all right, good. So let's run this application. So basically it starts this application, jar file, and we are going to use Google Spanner connection properties, and we are also going to load the schema, those tables, and this parameter means that I'm going to connect to my Spanner and print some statistics like the total number of trades and blah, blah, blah.
Okay.
So we are connecting, but we failed. So Spanner says that create sequence statement is not supported. So generally, what it means, if you go to the this one, so this operation failed. So like from the feature perspective, it's not supported yet. And for me, it means that I need to, update my application. But I don't want to do this right now because I don't want to come up with another solution of, let's say, how to generate IDs. Probably a good solution for me would be to use, I guess Spanner has this in its own SQL engine. If not, you need to use some other third-party solution to generate unique IDs for your distributed database. So, which means that, I cannot say that Google Spanner is feature level compatible. At least its feature level compatibility is probably low or average. Lower. So it's not high. It might not work for many applications. Now, let's do the same exercise for CockroachDB. Let's run. Cockroach actually, it's the same. Also, we use PostgresSQL JDBC driver, and I'm connecting to my serverless database. Excellent. That's the wire compatibility level in action. So we are connecting. I created the tables, etc., but then I've got another exception. So the problem here is this line of my code. That's my application. I'm refreshing. I used refresh materialized view. So Cockroach supports creation of materialized views. I managed to create it, but I cannot refresh it. Probably that's some issue, bug, or unsupported. Anyway, this is an issue that can easily be fixed. That's not a showstopper. I can certainly, let's say, come up with another way how to refresh materialized view. So that's why, let's say that from the application standpoint, I said, it's not a big deal. Let me just run the same application, but I'm saying do not refresh this view. So basically, I'm turning off this section.
The flag.
So if I do this right now, wonderful. You see, I connect it, and I'm receiving from PubNap. I'm inserting everything in CockroachDB. Pretty good, right? I had some bumps, but this one is like for this trivial application, it's not a big deal. So I would say that at least from the feature level compatibility, I can say that it's much better than Google Spanner. It's not low. It's good enough. So finally, let's go to the databases that are based on the PostgresSQL source code. We are getting to Amazon Aurora. With Amazon Aurora, the same stuff. The only difference that I'm connecting to my instance on Amazon, and I'm going to use these settings. We are connecting it to Aurora. We created everything, and no issues with the refresh view. So generally, right now, we are getting trades. The trades are going to be inserted. I'm printing some statistics. Every 5 seconds, I'm printing the statistics, and the view, materialized view, is going to be refreshed. And that's not surprise. It's easier for Amazon Aurora to do that because they use the PostgresSQL source code. And the final thing is YugabyteDB, my daily duty, so to say. Let's copy this command. And again, we will also create this. While it creates, I'm using YugabyteDB managed. Again, the same PostgreSQL driver. You can use Yugabyte Smart driver that load balances all the requests, but you can just use JDBC driver of Postgres. And, I'm connected, and similarly to Amazon Aurora, no issues with the refresh view, materialized views, because we are built on the PostgreSQL source code. So that's at least what to conclude here. At least, if to judge by this simple example, like the feature level compatibility of Aurora and YugabyteDB is better, if to judge by this example, than of Spanner and CockroachDB. But for them, for Aurora and Yugabyte, they're built on the PostgreSQL source code, which is kind of more interesting and more straightforward if you wanted to become feature level compatible. So let's stop this.
Absolutely.
Any let me return the mic to you at least for a minute. Any remarks, any questions?
Absolutely. I think it was a great demo just to show different types of compatibilities and where things can go a little off for certain database, but sometimes it's not a big deal because you can always change the way you were doing things in the database. But yes, I think it depends on where these databases decide to invest on, if they want to become more and more feature compatible or not. And I think it depends on the types of migrations or the types of applications that are migrating to these databases, right? So it is very interesting to see how simply if you're working at a Postgres database, you want to migrate, how simply it can be done, and how much compatibility matters. It reduces the pain points and it makes certain things easier. So it's definitely easier to migrate to a Postgres compatible database up to certain percentage than it is to migrate to a completely different database. So that's for sure. And I think for architects and for developers, understanding this part, like what does compatibility means and different types of compatibility, I think it is really helpful. So I don't have further questions on the demo. So it was a good one.
Yep. Then let's do the last one. The e-commerce application. Let's say that because application developers and architects are gonna watch us, right? Once the video is uploaded, and those guys build something that is more sophisticated than what we showed you. Let me show actually this e-commerce application. This e-commerce application was created by folks at Hasura. Hasura is a GraphQL engine. Let me quickly show you a picture. Where did I have a picture? I want to show you architecture, application architecture view. I lost it. Run application locally. Yeah, I think these steps. So that's a quite sophisticated architecture. You have Hasura GraphQL engine that used Postgres by default. You have front end written in Next.js, and you have back end in Next.js. You have integration with Stripe, using authentication with JWT. You also use Minio as a storage if you want to run it, not only in Amazon. And generally, like our goal was when I joined Yugabyte, I said, hey, actually, I want to did my own validation. I said, yeah, we keep saying that YugabyteDB is PostgresSQL compatible, but let me take some advanced application and migrate it to YugabyteDB. And surprisingly, I took this application and everything went well. And after that, I was convinced that at least when we say that we are PostgresSQL compatible, then there is something serious behind those words.
Yeah.
So let's use this application for the final test. I'm not going to test this application for Google Spanner because it doesn't make sense. There are many features that are not supported by Spanner, such as stored procedures and triggers. They are not supported. But I will run it against Cockroach, Aurora, and YugabyteDB.
Absolutely.
So let's quickly do this. My final file. So let's start with Cockroach. It's going to run in Docker. At least the application will be started locally on my machine, but it will be connecting to your database in the cloud.
Okay.
So I think that, just in case with Docker, you need to clean usually all this stuff.
Yeah.
Especially if you're running the same application across several PostgreSQL compatible databases, you never know what's stored in your containers. So let me do the cleaning once again.
Yeah.
All right. So now I'm starting this application, and in the application settings, I have CockroachDB is my target database. Okay. What does it do? Docker down. Oh, no. That's wrong. I need up. That's what I need. Start the demo.
Yeah.
So what happens right now, this application consists of several services. We have GraphQL engine, we have Next.js engine, and we have Minio. So what happens here, folks? Let me show it to you. It didn't manage to run because it says that, let me stop it. The Postgres server, CockroachDB, responded saying that pgcrypt extension is required but not supported. So generally, that's the runtime level compatibility talk. Because runtime compatibility, your database need to look like and behave like Postgres, which means that you need to have system catalog, error codes, extensions, and much more. Unfortunately, with GraphQL engine, this is not supported. So my course of actions here is, what should I do? Probably I need to change GraphQL. Like I need to use a different GraphQL engine, right? Not Hasura, but something else, because another engine. So I need to change. It's inevitable. I need to change my application code. But let's check the schema, the final one, because I can try to load the data directly to CockroachDB because I have this integrations file. Let me show it to you. And actually, the schema is advanced because that's a quite real application. We have stored procedures, we have triggers. Man, we have a lot of stuff here. I just want to try to load this directly to CockroachDB just to make sure that my efforts will play out if I switch to another engine.
Yeah,
that's Cockroach, right? Yeah, it creates almost everything except that triggers. You see, triggers are not supported. Stored procedures, I think. Yeah, stored procedures are not supported. I actually checked. I following the engineering director of CockroachDB, nice guy. He gave some hints that stored procedures are coming, which means that at least stored procedures should be available at Cockroach at some time in the future. But triggers are not available yet, and some other kind of functions. Anyway, what it means, that's the difference between databases that are built on the PostgreSQL source code and those that are trying to catch up with PostgreSQL. So Cockroach folks need to, just to introduce those features. We usually just take those features and we adapt them for our storage architecture. Anyway, I mean, it happens. So, which means that for this application, e-commerce website, if I decide to use it with Cockroach, I need just to certainly work on the application source code and decide what to do with missing features. Next, let's do this for Amazon Aurora. So I'm going to my settings and I'm saying, hey, e-commerce website, now go to Amazon Aurora, right? That's Aurora. Yeah, that's Aurora.
Yeah, that's Aurora.
Let's do up. Starting, done.
So we expect that it should be like 100% compatible because it's Postgres basically.
Yeah, for this one, it's not 100, it's probably like 95. It also depends like what version of Postgres you're running, because it's like this.
That's right.
Postgres is the main train. And the Postgres, like if Amazon Aurora supports Postgres like 14th, it means that it doesn't support the latest changes that are in the master branch of Postgres. But at least for this application, it's built on some version of PostgresSQL, and Amazon Aurora might already support that SQL. So you see, it's running, it's good. And the next step in this application, I need to apply metadata and seeds. So let me start this and I will explain you folks what it means. No, I don't want to upgrade my command line right now. So metadata means that it's the same as create the schema, execute all of those create statements in that file that we tried to run against Cockroach directly. And the seeds mean that load the data, load the sample data. So let's do this. Metadata is applied. So right now we are applying migrations, which mean the data. Migrations. Yeah, migrations is the create statements, the schema, and right now we are loading the data. It will take some time because the data set is quite large. But for Amazon Aurora, it will be faster than for YugabyteDB, at least right now, because for some reasons, first, I have not optimized this code. Because in YugabyteDB, there are many techniques how you can load your data in a distributed database much more efficiently.
Okay.
And also, I'm running a multi-node YugabyteDB cluster. So right now, that's why.
So this, Aurora, I have a question. So Aurora will also be a little bit slower if I have more number of read replicas, right? Because it will synchronously, it will synchronously, try to kind of take that replica and do the replication.
Because they do care. You use Aurora if you certainly want to boost reads, but also you want fault tolerance. Because if let's say a primary node of Aurora runs in the US East, and then that region availability zone goes down, becomes unavailable, you can fall back to the replica that is in different region. That's the beauty of Aurora. That's what it does. This is what it's actually designed for. Faster reads, right? And also much better fault tolerance. You can certainly take your vanilla Postgres. We're not saying that you cannot do this with Postgres. You can do this with Postgres. But it's like you will be solving the same engineering problem over and over again. I mean, when you remember I was talking about that first project, the high performance system backend with Postgres. Our Postgres instance was sharded. We actually ran multiple Postgres instances like 13 years ago. And we had a special layer that would receive those requests and decide to what shard to send that request. In every request, we had to specify a special sharding key so that our layer will decide to what instance. Like even those days we did. And you can do this in more sophisticated stuff with vanilla Postgres right now. But the question is, do you have time for that? Do you have engineering resources for that? Do you have, that's why Aurora, that's why other PostgreSQL compatible databases that simplified some of their frequent tasks and needs. So, seeds planted. Now, no any exceptions, but let's go to that application because at least you will see how it looks like. It's beautiful. So what happens right now, by default, when you run the first request, Next.js, guys, if you're not familiar with Next.js, it needs to compile your code for the first time into the HTML and JavaScript and blah, blah, blah. So this is why it took so much time for the first request. But yeah, that's my store. Do you want to buy a mat, or do you want to buy anything else? You just go. You have product catalog. You have recommendation reviews. You can add to the cart. So like good, right? So Amazon
Yeah.
Aurora passed this test. At least we can state that Amazon Aurora is runtime compatible because that
Yeah.
extension exists. Like feature-wise, it supports procedures and triggers and God knows what else, which will be easier for you. I mean, right?
Yeah.
And
Absolutely.
let's do the final test. Let's
Yeah.
do the final test because for YugabyteDB, now, as I said, it's better to clean Docker. Now, where is my which one? I have so many windows. Yeah, that's our window. So let's stop this.
Yeah.
We are stopping our application. Come on. Why does it take so much time to kill yourself? It's like it doesn't want to kill itself.
Just nuke
So
everything. It's difficult to
everyone
kill.
wants to leave, right?
Yeah.
So yeah, let's just in case stop all the containers. And then I have this clear demo resources. I just remove all the volumes because the application can remember something. Because Aurora and YugabyteDB are PostgresSQL compatible, it might treat, as Aurora. I don't
Yeah.
want that to happen. So now, yeah, before I do this, let's enable YugabyteDB. I'm saying I want YugabyteDB.
Yeah.
And up. Let's start it. Yeah, so while we are waiting, if you might have any questions we can discuss, because it also will take time right now to reboot
Yeah.
everything. So feel
just
free
just
to.
to just to make it a little bit clear to our viewers, like what exactly we are trying to do. So we have an e-commerce application, and that is built on top of, let's say, Postgres database, and now we are trying to migrate the data to each of these databases, and then changing the properties such that our application points to the specific database, for example, Aurora or YugaDB, and we showed the demo that it works. So the migration part itself was pretty easy. Of course, it depends on the application, depends on how much data you have, but ultimately the pain points are really less because of
Mhm.
all these compatibilities that we discussed prior to this. So it's pretty cool actually, so for developers, they don't have to worry about, if it's a basic applications, they don't use very custom Postgres specific features, then it's so easy for them to just migrate off of Postgres and move to a different database. So yeah, I think it makes a lot of sense. And I think you briefly mentioned why would you use vanilla Postgres versus all these other databases. uh, but I think the point is that you can always start with the vanilla Postgres database, but then you will end up having this fault tolerance and high availability and scalability, because you can't horizontally scale unless you want to shard the database, but you don't necessarily have that much development effort and cost to it, right? So it's best to use the already existing databases that are wire compatible, feature compatible, uh, with PostgresSQL. So I think it makes a lot of sense. Instead of building on our own, it's best to use these amazing, cool technologies that are available out there, right?
Yeah, that's a wonderful and straight to the point statement and conclusion, because
Yeah,
I have the same vision. I mean, when you decide what database do I need to use, should I use vanilla,
yeah,
Postgres? I mean, man, it all depends on on the state of your company, of your project, right,
yeah,
of your application. Because especially when you're a startup company, if let's say you are one of the departments at JP Morgan or at
yeah,
Target or I know at Tesla, I mean, if you're just starting small, just start with Postgres, but make sure that you will be able to, if you have a big vision in mind,
yeah,
you know that, all right, so right now probably all I need is Postgres and I can run it like this way. I can
yeah,
probably use Google SQL, which is manage Postgres, and I will pay this one, but it's enough for me. Once I become a hit, once I get a certain metrics like hundreds, let's say thousands of active users daily, then I will start caring of fault tolerance
yeah,
and then let's say how can I scale reads and writes, and then how can I scale across continents, what database to use. If you use, let's say, Postgres, then it's going to be easier for you to migrate to any PostgreSQL compliant database, and
Absolutely.
and you will pick a database that you like. So
Fair
while
enough.
we were talking, so actually here is just to explain the guys. Uh, yeah, there was one of the exceptions. It's disappeared. That exception, guys, if you paid attention, that exception said that my GraphQL engine were able to connect to YugabyteDB, and it tried to load the product catalog because that happened before I closed the application tab, and YugabyteDB responded that there is no any data yet.
Yeah.
So that was harmless exception. It was just, let's say, there is no any data and my
Yeah.
application screen would be empty. But
Yeah.
right now I loaded all the data,
Yeah.
and
Sounds good.
let's load
Let's
this
look at our
application.
e-commerce
Yeah,
application.
yeah. Right now we have this e-commerce application, and right
Yeah.
now the same application, but it works and uses our multi-node YugabyteDB cluster.
Awesome.
You can click, you can review. It's warming up right now. It's Next.js compiles different code. That's why it takes time. So where is my card? Yeah, you have
Yeah.
this checkout. You can do this, and that's Yugabyte. Yeah, the nodes. So my cluster is in South Carolina. I have 3 nodes in different availability zones. That's what I have. With this configuration, I can withstand. I can lose one of the zones, and I will be
Yeah.
operational if I need to scale across regions, etc. So probably one conclusion,
Awesome.
because Amazon Aurora and YugabyteDB both passed all of my tests, right?
Yeah.
But what's the difference between Aurora? Because we figured when we should use Postgres, right? Probably start with Postgres by default and then decide if you need to switch to any uh, advanced, let's say,
Yeah.
Postgres compatible database. But what's the difference between Aurora and YugabyteDB? So Aurora, again, use Aurora if all you need is just to, I mean, if you need to scale reads, right? And if you run in Amazon, if you use Amazon as infrastructure, if you want to scale reads, you can use read replicas.
Yeah.
And finally, if you want to withstand like different region level outages in Amazon. With YugabyteDB, it scales, it's horizontally scalable distributed database, which means that it runs multiple nodes that are equal in the sense that they are both writers and readers. You can run them the same across multiple zones and regions. So basically, with that configuration, you are boosting both reads and writes. It's not about reads only; it's about reads and writes.
Yeah. Yeah.
And then you can come up with some other sophisticated configurations. It's like you can deploy read replicas also in, let's say, my primary cluster is here in the south, but I have some sophisticated configurations when my primary cluster is in the United States, but then I have read replicas in like in Taiwan, or I can
Taiwan.
have a more sophisticated configuration when my cluster actually spans across multiple countries.
Yeah.
And for that cluster, I'm using so-called geo-partitioned. It's like when you in
Yeah.
your database schema, you're defining a special geo column, and based on the value of that column, your data will be either located in United States or in Taiwan or in Frankfurt, and then the queries and updates will be synchronized in that region. So like a lot of this stuff, but basically it's horizontally scalable and scales
Yeah.
both reads and writes, and you can scale it vertically, horizontally.
Yeah.
Second, it works not only in AWS, right? It works across all of the cloud regions you like and your premises. And finally, it's open source, similar to Postgres. It's built on PostgreSQL source code, and also it's open source. It's licensed under the Apache 2.0. You can take it and do whatever you want with YugabyteDB, similar to Postgres. What I do here, I'm a lazy guy. I'm running YugabyteDB in as a managed service. I don't want to
Yeah.
deploy it. So
Awesome.
that's pretty much it, man.
That's very cool. That's very cool. I mean, migrating an entire application, like almost like a real world application, from Postgres database to another database itself is a big challenge, and like showing it live is an amazing thing. So I think our viewers will get a lot more curious about Postgres and all the Postgres compatibility levels and the other database that are solving these problems at much higher scale, right? And I learned a lot, and I am sure that our viewers also learn a lot after watching this episode. So for our viewers, if you like this episode, do smash the like button and subscribe to the channel. And I hope you liked it and you are more curious to learn more and more about Postgres and why it is rising, why it is growing with time. So thanks a lot, Dennis, for coming to the episode, sharing all the valuable lessons, and showing us the compatibility levels and also giving this wonderful demo. So thank you, and I look forward to collaborate with you more in future.
Sure, sure. It was a pleasure, and I like to do those demos. Like especially when something fails, because you can then spend some time, just trying to
Yeah,
debug. But today, everything was running
everything was,
normally,
yeah,
which is
working.
good. Like we saved, let's say, several minutes for the guys
Absolutely.
who are watching us, and certainly let's stay in touch, because we
Yeah,
might dig deeper in certain areas when it comes to applications and databases. And also, folks, we will share with you some of my favorite books, because if you want to learn more about database internals or distributed databases or distributed systems, there are probably uh, two or three my books that I would recommend to everyone. And
yeah.
I think two books are published by Aurora.
Mhm.
I just need to tell you, I will share with them, so like you can
Yeah,
get
absolutely.
you can have
I'll
a
I'll
chance to
add,
learn more.
add those links to the description of this episode, so you can refer to those books and learn from those books about database internals and be more curious in like how these databases are working and about what are the internals. So great. Thanks a lot, Dennis.
Thanks a lot. Thanks a lot, man. See you